right, hello everyone. Welcome to the live stream. I'm your host, Stefan Burns, geologist, geophysicist, space weather guy, and we just had a big magnitude 7.6 earthquake off the coast of Japan. A tsunami threat has been issued. This is right in the location where there was an anomalous earthquake swarm. This just occurred, as you can see. Thankfully, it was at 53.1 kilometers in depth, which means it's less likely to produce a big tsunami. The tsunami for this has been estimated to have a wave height of 0.3 to 1 meters. So, I mean, a 1 meter wave at the beach is pretty big, but it's not a mega tsunami or anything. As far as we know, it would have already struck. This occurred at 14:15 Universal Time, and right now it is 15:37 Universal Time. So we're getting to about an hour after it occurred. It would have already came in and hit all the coastal areas. So this was a big earthquake, and sorry to break it to you, if anyone's watching this that's new, this could be a foreshock. This anomalous earthquake swarm that we had off the coast of Japan about a month ago, a little bit less than a month ago, it was almost identical to the earthquake swarm sequence that occurred off the coast of Japan before the magnitude 9.1 Great Tohoku Earthquake in March of 2011. So we were looking at that swarm. I broke it down in terms of the number of earthquakes and their magnitudes and the actual seismic energy release measured in watt hours, and we looked at the spectra for it. Basically, it's a perfect match other than we didn't have a magnitude 7 earthquake for that swarm. The highest was a 6.8. There's a 6.8 at 6.4. The foreshock for the Great Tohoku earthquake was 2 days before. It was a magnitude 7.3. So on March 9th, on 2011, there was a 7.3, and that's a big earthquake. You could be, okay, that's it. Well, then the magnitude 9.1 struck. So we can't rule out the fact that this is a foreshock, because now everything has been identical to what happened with the Great Tohoku earthquake in March of 2011. And in fact, if this is a foreshock sequence, I can't say definitively if it is or isn't. If this is a foreshock sequence, then this is indicating that the event that will follow will be even bigger. That is certainly possible. Now you may be like, well, a magnitude 9.1 is a huge earthquake. How can you get another big earthquake or even larger to follow it just 14, 15 years later? Well, yeah, that's a good point. It makes it a little bit less likely, for sure. It is a huge release of energy. Remember though, that we had a magnitude 9.5 released down here in 1960. That's a big earthquake. And then we had a 9.2 in Alaska in 64. So those earthquakes are much larger. Specifically this 9.5. When you do the scaling for an earthquake, it's going to take multiple 9.1s to equal a 9.5. And we can actually do the math. If we go to our earthquake calculator, because we're on the topic, let's go into it right now. I hope all of you are doing well, and hopefully no one's been affected by this in a serious way. I mean, the 7.6 is severe shaking, so people in those areas certainly felt the shaking. Thankfully, again, it was at about 50 kilometers in depth, which is good. This is our wavelength calculator. We don't want this. We want earthquake calculator. This should do it right here. Okay, so let's type in 9.1, and then we'll do the 9.5. Just to give you a sense, okay? A 9.5 earthquake is 4 times stronger in terms of energy release. So that earthquake that occurred in South America, way back in the day, 1960, you would have needed 4 back-to-back-to-back 9.1s to equal that single 9.5. So if we're talking about the Earth on a global sense, and you had that much energy release here and that much slip, and then you had a lot of energy release here, a lot of slip. We've also just had that mega quake in Japan, Kamchatka, in July 29th of this year, the magnitude 8.8. You know, if there's this balancing aspect which exists, then we could be looking at a really big earthquake here. At least some alarm bells in my mind are going off for that. I'm not here to say it's a definitive thing. I think that's foolish. Anyone that's 100% on this is going to happen is foolish, but we can't rule out the possibility. It's a heightened probability. And because of the earthquake swarming being so similar, that is certainly the case. So we have some space weather factors also. We forecasted this on the channel. So when that swarm started to occur, we were forecasting that. In fact, we were looking at Japan for a big earthquake even going back to this summer of 2025. So we got one. We got one. Unfortunately, we got one. Because when a big earthquake strikes an area like this, it affects people. So it's not something that we hope for, but it's something that we want to accurately track and hopefully warn people of, because that could help a lot of people. So we'll go through some of this stuff. Big tsunami threat for Japan when that first ruptured. Now you see here 0.3 to 1 meters. We just clicked non-USA, Canada Pacific threat number 2. Let's just read this. It's probably going to be fairly general for all of them. The tsunami forecast is updated in this message. An earthquake with a preliminary magnitude 7.6 occurred in the Hokkaido, Japan region at 14:15 Universal Time on Monday, December 8th, 2025. Based on all available data, hazardous tsunami waves are forecast for some coast. Waves reaching 0.3 to 1 meters above the tide level are possible for the coast of Japan. Tsunami waves are forecast to be less than 0.3 meters above the tide level for the coast of Chuuk, DPR, the Democratic People's Republic of Korea, Guam, Johnston Atoll, a whole bunch of islands. You can see them there. Actual amplitudes at the coast may vary from forecast amplitudes due to uncertainties in the forecast and local features. In particular, maximum tsunami amplitudes on atolls and at locations with fringing or barrier reefs will likely be much smaller than the forecast indicates. Those atolls and the reefs break up any sort of waves. That's why it's rare for San Francisco to get tsunamis, because there's a big reef kind of offshore, and that breaks things up. For other areas covered by this product, a forecast has not yet been computed. The forecast will be expanded if necessary in subsequent products. Okay. Now, I think there's a tsunami simulator that we can check out. Yes, let's put in a 7.0. Maybe it's not in existence anymore. Maybe not. Now, before we get into looking at the details of this swarm more, and maybe finding some imagery of the shaking, I'm sure that we got probably lots of videos coming in from this city right here, because that's fairly close by. I want to show you the space weather conditions because, and I also kind of want to show you what we've been forecasting, because my official, I put out a tsunami or a high magnitude earthquake alert for Japan in November. And I was basically saying if we get all the way to the end of November and nothing happens, then the forecast probability goes down a little bit. Because that was kind of the main time window. So it looks like things extended out a little bit, but we were talking about this back in early November. I mean, I very clearly have that video. So let's look at real-time solar wind. The main thing that we track, at least I've started tracking for earthquakes as it relates to space weather, is solar wind density. It really seems that solar wind density is the key, okay? When you have these coronal hole high-speed streams that sweep by the Earth, they increase the velocity, they decrease the density. Here we see the solar wind density in orange. Up top is our magnetic field characteristics. We have our density, our velocity, our temperature, our magnetic field readings. Basically, this is showing the volatility in the magnetic field. You'll notice that we're very low right now. We're waiting a big solar storm impact, okay? Solar storm impact has not come in yet. Look at our density. It has gone under 1 particle per cubic centimeter, which is the main variable that we track. If it hits 1 or under, that seems to be kind of the key threshold. We had the magnitude 7 just recently in Alaska when it was hovering in between 1 and 2. 1 and 2 is still quite low, but it's really when it goes under 1 that the solar wind density is low, and that consistently times up with the highest magnitude earthquakes. That happened back in 2011. We'll check that data out, okay? But let's go to 12:15 universal time. There is our solar wind density, 0.19. So 0.3 to 0.19. It was nearly just a third of 1. So only 0.2 particles, roughly, per cubic centimeter at the time of that earthquake. Normally, you'll see a particle density of like 3 or 5, something like this. Even higher, it can go up to 8. There's just more mass and energy around the Earth when that's occurring, because we're measuring the solar wind. So the Earth is one tiny little bubble, you could say, immersed in a larger ocean. And the Earth has a lot of mass to it, right? It's very, very, very heavy compared to the very low density space around it. But when you are changing the density of space around the planet by orders of magnitude, right? Going from 8 to 0.3 is a big jump. It's more than an order of magnitude. That seems to affect plate tectonics. Now, exactly how, we're still figuring that out. But we see time and time again, this happened, so we can't ignore the signal. We instead need to figure out what is actually happening, instead of saying there is no effect and then playing the fool. So stress builds up at fault junctions and plate boundaries because of plate tectonics, but there are other forces that are working with the system as well. When you have a fault that's at a critical stress, it will then rupture when it's pushed over that stress threshold. Just like a normal person too, right? If you push someone all the way to the limit, they're going to freak out on you. Same deal with faults and plate boundaries and more. And sometimes these zones will give you warning signs with earthquake swarms, which is what occurred in Japan, both in 2011 with the 9.1 beforehand and just in the past 6 weeks. So we have a big solar storm impact coming in following this. That's going to come in today. That's expected today, less than 24 hours now. But as of right now, conditions are very quiet and we have our solar wind density below that critical threshold, which we track for high magnitude earthquakes. So the Japan forecast has, in fact, unfortunately come true. And anyone that paid attention to that back when that was issued was much more prepared than others. Let us look and go back in time to look at these other earthquakes, and we may be able to get them with our 30-day view here. I'm not sure how long ago those were. Yeah, okay, so we're just in the time window for our 30-day view. Here we have our earthquake swarm right here, and we see the location is slightly off. Okay, but in the grand scheme, this is all the same zone. So this was our big swarm. We had a 6.8, let me move over here. We had a 6.8 for our top, a 6.4, same day. This is all November 9th, so almost just exactly a month ago. And then magnitude 6, 5.9, actually something like 25 magnitude 5 earthquakes or more, and then tons of magnitude 4s. So that's the earthquake swarm that occurred off the coast. And if we zoom out, we had the Great Tohoku Earthquake swarm roughly in this zone right here. But in fact, it's maybe more like right there. But in fact, that magnitude 9.1 earthquake caused everything in this section to rupture. I mean, there was earthquakes across this entire zone after the magnitude 9.1 in 2011 for months and months and months. There were these big earthquakes popping off. So now we have a 6.4, 6.8, 7.6, and this could be still foreshock activity. Could be all she wrote. We hope that's the case. I think that's probably the highest likelihood, but I don't think it's 95.5%. I think the chance that this is a foreshock for something bigger is actually quite high. Maybe not 50%, but pretty darn close. Because it's eerily similar to what occurred in 2011. And what we see is that, well, the Earth often just kind of goes through the same rhythms over and over and over. So this is concerning. Let's look at our 2011 earthquake data, and then we're going to go back to the solar wind data so you can see what I'm talking about. Yes, okay, so here we have our foreshock activity for the Great Tohoku Earthquake right here. This is March 11th, first thing in the morning, Universal Time, going up to 1 minute before. You see how this occurred. 7.3, 6.5, 6.0, 6.0, 5.9, a whole bunch of 5s, a whole bunch of 4s. Almost identical, as you can see. Almost identical to what occurred over the past month now. The difference is that this was all much faster in time. So it all occurred just in the span of a few days, whereas ours occurred over the course of a month. And that magnitude 7.3 ruptured in that swarm location, whereas the 7.6 occurred just outside. So that does, I would say, reduce the probability a little bit of it being a foreshock connected to the whole thing. But it's possible because here we see the scaling. The overall energy release scaling for this across the different magnitude brackets is almost identical. And in fact, now what's happening, it's more significant. So because this is a 7.3, you have a 7.6, 7.3, 7.6 is a lot bigger. That 7.3 was at 32 kilometers of depth 2 days before the big earthquake. Let us go back to our earthquake calculator and we'll type in 7.3 and 7.6. And a 7.6 earthquake is 3 times stronger in terms of energy release. So this is big. This is big. Now what we have happening off the coast of Japan is even more significant than the preliminary activity before the Great Tohoku Earthquake, which was a warning sign. We saw that warning sign. We weren't ignorant to it. We talked about it on the channel. And well, yeah, now we're seeing it. If we just go to YouTube really quick, I just want to show you, because it's important. Like we want to help each other on this planet. At least I hope so. Oh, not that. We want to help each other on this planet and do our best to understand the planet and be good caretakers of her and make the world a beautiful place and all live harmoniously together. And so we need to pay attention to this stuff. So we go to videos, we go down here, Japan's at huge risk. The chance of a magnitude 8 megaquake striking Japan just went way up 4 weeks ago. We talked about the earthquake swarm and more. If you go further down, you'll see some other videos discussing Japan as well. That was back in July when there was a lot of indications that something would happen. Nothing happened back in July, but certainly once we had that anomalous earthquake swarm pop up back in November, as we just saw a month ago, well, that was indicative that something bigger was coming. And well, that's exactly what happened. And now we have a big solar storm impact coming in. So the receipts are all on my channel. And I only show you them because I want us to take these things seriously, right? Because there's this habit that people have of dismissing something, and when the thing occurs, they're now over there dismissing something else. And it's like, no, go back and see that the thing actually occurred. And maybe you need to reevaluate your opinion or belief or just see the data. Let's look at the data. Great Tohoku Earthquake 2011, we know the day. Let's go back in time. Let's see the solar wind properties. This is why we check the solar wind density. So we go to 2011 here, and it was right in the zone. Let's do that. Okay, and we want to zone in specifically on, again, yeah, you can see it actually from, see right there, you can see the solar wind density dropout compared to the rest of this time frame, which is about a year or so. Yeah, 1.2 years. So you'll see the fluctuations here, and we'll zone in on it. But sometimes you get these zones where the solar wind density stays elevated for a long time. You usually don't see strong earthquake activity during those high density zones. Then you have other times just kind of dropping in and out. But look at this, another very high density zone. I bet if you check that time window there and that time window there, you won't get really any big earthquakes. So this is something that we need to do some more research on. That's a plan of mine very, very soon. But here is our solar wind density for 2011, okay? We had big dropout here. This is late February. It actually went off the scale. And then it went back up. We had this huge high-speed stream impact right there. Look at that. It goes down. We get our solar wind density to drop. It's March 3rd. It's really low, anomalously low. The lowest readings that we get from our probe in space is 0.1, so it could have actually gone below that. We don't know how low it goes. But let's say you're at a particle density of 1. That's already low, okay? Let's say 5 is normal. If 5 is normal, 1 is already 20% of that, okay? So 1 is already low. You go down to 0.1, that's now an order of magnitude lower. You go down to 0.001, that's 2 orders of magnitude lower than a value that's already low. So that change in the energetic flux and particle density around the planet does seem to have a big effect if you think big. You got to think big. Here we see it kind of went up there, and then right during the earthquake, it was also still anomalously low. Right here we see it was at 0546, and well, we were right in that super low particle density for the solar wind window there. So huge dropout in the solar wind particle density, and then it also was extremely low at the time of the earthquake. And you'll see that we also had same day a geomagnetic storm come in. So look at this. We have this coronal mass ejection impact. We're having the same thing happen today, folks. In less than 24 hours, we are going to have a solar storm impact. I can show you that data. It's really quite clear. So here we have our last solar storm, not the last one, the last big solar storm that launched from the sun. That's the first one, and then we'll see this second one right there. That's from a 8.1 M-class solar flare launch, a coronal mass ejection out in space. There was a 1.1 M-class flare before that, the little puff before, and then we get the big explosion. As you can see with this differential view, boom, there we go. And here we see our coronagraph. So now we're looking at a wider view of the sun and solar wind. This is the sun right there. And so it's actually probably more like right there. And we see this big explosion going out. You'll see actually a shock wave go off more here. And then the bulk of the plasma you'll see is right there. So these sort of explosions can create a shock front, and then also just the larger plasma wave following behind it. That is coming in right now. Here we see our NOAA space weather model for that. Impact expected 6 a.m. Universal Time, December 9th. Here it is. This is top-down view, Sun, Earth. We see it coming right in. This is plasma density. This is the velocity. It's higher velocity. This is south-north view. So it's like a vertical slice. And we see that also going straight there. If it was to go south, that would bypass the Earth to the south of our orbit. If it was to go to the north, same deal. That is a direct shot on both top-down view and also our side view. Plasma density spikes up. Our velocity spikes up from that impact. This is what's expected. It's a model. How strong this storm actually will be remains to be seen. They expect a G3 storm from this, but it could get a lot stronger. And it could get a lot stronger because now we have more solar storms inbound. So we just had recently, if we go to our X-ray flux, we can look at our recent solar flares. And here they are. We'll look at our 7-day, okay? But this was our 8.1 M-class flare. We actually just had a stronger solar flare today, and this was a 1.1 X-class flare. Now, this did not produce as nice of a coronal mass ejection as this 8.1. It was more of an impulsive event, so just a quick like this. But there was a double M-class flare that occurred right before, which also launched something our way. And if you go to our 3-day view, we've also had some follow-up flares right there, right there, right there. So there's been a lot of activity for the past 3 days from these big sunspots on the sun. And if we go to our NASA space weather models, this is the first one. This is for the, what is this for? Well, there's two, so I want to make sure I get the right one shown. This is from the 1.1 X-class flare. Okay, so here it is. This is from the 1.1 X-class flare. Earlier today, they have a space weather model showing it. Again, top-down view, vertical view, mostly off to the side, but still impacting Earth slightly with its flank right there. And then we have our model for the 2.4 M-class flare right here. And so we click that and we get another direct hit to Earth. As you can see with our top-down view here, Earth is the orange dot, that's the sun. Here we see our vertical view again, boom, boom, just like that. So any one of those independently would trigger some elevated geomagnetic storming, which is just magnetic fluctuations across the planet getting stronger. But we're having them all combined in time. So we already have the solar storms coming in from the M1.1 flare, the M8.1. Now we have the coronal mass ejections coming in from those two flares. Now we have the coronal mass ejections coming in from this double M2.0 and 2.5 M class flare, and then also this 1.1 X class flare. This is going to be over the next few days. So yeah, and we saw that when the Great Tohoku Earthquake occurred, magnitude 9.1, that also had that coronal mass ejection impact just afterwards. So it's strange how these things rhyme. Like, they are so synchronistic. That does not mean we're going to get a magnitude 8.5 or greater earthquake off the coast of Japan, but it certainly makes you think. It certainly makes you think. And I think the probability still of there being a big earthquake there is quite high. But if we go back, again, we see that it is slightly off the location. I think this is our map here. Yeah, it is slightly off the main location, which is kind of odd. So I would say if there is something bigger to occur, it's going to be in this location and not here. It's hard to say, but if I had to really put chips down, I would say a bigger earthquake could occur right there. And if this earthquake scaling that we've been checking does in fact pan out, then we could be looking at something greater than magnitude 9. Even magnitude 9.9, 9.2, 9.3. I mean, it's hard to say. We don't want these things to occur, but we got to look at it as honestly as possible, and that is certainly in the cards. So hopefully this is all that she wrote as it relates to this. Hopefully there's nothing else that's going to occur from this swarm and now this magnitude 7.6 earthquake. One of the strongest earthquakes of the year. We can search our earthquake catalog. In fact, let's search the other one. Let's look at our earthquake catalog for the year to see our biggest earthquakes. Great. So here are all our earthquakes, magnitude 6.5 or greater for 2025, which has been one of the biggest years on record for seismic activity and global seismic energy release. So an earthquake, the ground is shaking, right? There's some sort of rupture underground, some movement of mass, vertical, horizontal, a combination. There was a big shift in Earth mass suddenly, which then releases a tremendous amount of energy, sound waves. You have compressional waves, you have shear waves, you have surface waves, okay? But this is simply just a massive release of energy. So when you have big earthquakes, you have just energy being liberated from more locked, bonded systems being released outwards. So in terms of the Earth just spinning through space and just shaking up a bit more, this has been one of the strongest years ever on record because of that magnitude 8.8 megaquake that occurred off the coast of Kamchatka. We sort by largest magnitude, we see that right there. That was a big earthquake, but we've also had lots of magnitude 7s, as you can see. So here we have all of our magnitude 7s 8.8, 7.8, 7.7, 7.6. This now is the fourth strongest earthquake for the year. We had the earthquake that struck Burma earlier in March. That was a big earthquake. That was the 28th of March. That was a 7.7. The aftershock to the megaquake, 7.8, being the second largest earthquake of the year. This 7.6 now is the fourth strongest earthquake, though it is tied with also earthquake here, Drake Passage, which is south of South America. We see this other 7.5 that occurred there and a 7.4 nearby. And then we also see this earthquake here that occurred southwest of the Cayman Islands. That was a big one in February. And then again, Drake Passage, Philippines. This occurred recently. There was also a cyclone that was passing basically overhead as that occurred. So you see how these different things are connected in time, right? We see that sometimes earthquakes rupture with the movement of a big tropical storm, or even more likely a cyclone passing overhead or nearby. So they're called storm quakes. Some people still say, oh, that's not a thing. It's like, guys, we see this all the time. It's like definitely a thing. The gravity waves and the pressure differentials from the cyclone alter the pressure on the plates and can sometimes cause an earthquake. And so we see this connection with space weather as well. So if we go back to our earthquake calculator, let's type in 7.6 for what just occurred, and let's do a hypothetical 9.3 for maybe what could occur. Okay, 355 times stronger in terms of energy release for a 9.3 versus a 7.6. So as it relates to looking at these locations and the earthquake magnitudes and saying, okay, well, 7.6 occurred, so there's no chance of something bigger occurring. If the amount of energy that just simply needs to be released is of a 9.3 scale, this 7.6 isn't doing anything to dissipate it. It's 355 times less energy. So it's really just a warning sign. Now, if this was, again, like a 9.1, well, then you already had your big earthquake. But even then, a 9.3 is 2 times stronger than a 9.1. So you could have two 9.1s hit back to back, and that would equal 9.3. But this 7.6, just because it's a big earthquake, does not mean that that is the biggest earthquake for the area. It's certainly a possibility. I think that's probably the majority possibility, is that maybe this is it. But I don't think it's majority by much, like 50, it's like 50% basically. I'm right on the edge of like, is that the big one? Is there something bigger coming? It's hard to say. But yeah, we could definitely have something bigger occur there. If we're talking in the global sense about energy balancing out across the globe, that 9.5 that occurred in South America in 1960 hasn't really been balanced out anywhere. So that is kind of why maybe something bigger is possible for Japan. And we had this psychic who saw visions of a giant earthquake and tsunami striking Japan this year. So I mean, there's still a few days left. We got 3 weeks left, and she has actually a pretty good track record because she saw in her visions the 9.1 earthquake, the Great Tohoku Earthquake. So she's clearly in resonance with Japan. You know, she's Japanese, which makes sense that she would be resonant with her homeland. So let's see if we have this 7.6 yet in our, we don't. Okay, this is like a wave visualization tool. So that is what I got for you. I don't think there's really anything else to report here, but I will take some questions from the audience. So if you have any questions, then you can either ask them in the chat, or you can ask them attached to a super thanks. All the ones in the super thanks, I will certainly answer. If it is attached, if it's attached to one, if it's in the chat, I'll get to a few of them, but chat generally goes pretty quick, so I'll do my best. Way back, whenever saying the magnitude 5 earthquake occurred in Japan just 14 minutes ago, that'd be a follow-up to the 7.6. Let's check it out. And yeah, 5.5 earthquake here. And that's the latest that we got. And I think I can sort this to be, yeah, we don't want all magnitudes. Let's do this. Yeah, so we've had the 7.6 and a 5.5 follow-up afterwards. How many major earthquakes were there this week? SpongeBob with the Android 13 profile picture is asking. There have been 2 major earthquakes. So if we go to our 7-day view, we can see that we had, and we'll sort by largest, we have this magnitude 7.6 Japan, and then we had this magnitude 7 Hubbard Glacier earthquake that occurred just a couple days ago. Look at that swarm. Okay, let's just get this data really quick. 213 of the 487 earthquakes that have been plotted on this map for the entire globe are from this earthquake swarm in Japan. And this started up, this is actually a really good point. Okay, this is a really, really good point. I'm glad that you asked this question, SpongeBob. Look at the earthquake swarm that occurred after this magnitude 7. This is often what you get. When we had a magnitude 7 off the coast of California back in December 2024, down here, we had a very similar earthquake swarm. When there's a big event and then that's the big event, this is typically what you get. And so here we see that magnitude 7. We see the clear aftershock for that being the 5.8, and then you get a bunch of magnitude 5s and a bunch of magnitude 4s. Look at the list. This is crazy, right? So this was a big earthquake. People felt this in the area. Some of them commented on the channel. People felt this even out to Anchorage. That is kind of what you see after a big earthquake, is a big swarm like that. That's what we saw after the Great Tohoku earthquake. We saw this huge earthquake swarm that lasted for months afterwards. Let's go back to our 7.6 in Japan, okay? Now, this just occurred, but look at this. We got 2, okay? The Hubbard Glacier earthquake, that was like the moment the big guy ruptured, they all started popping off like crazy. Here we have a 7.6 and a 5.5. And this one occurred 18 minutes afterwards. It's basically been an isolated event. We haven't had a big, like, okay, that's the release, guys. Now all the faults are broken up and boom. This is also deeper. Now it's saying 44.1 kilometers. So what happens is the earthquake is a big rupture and then a lot of fractures occur underground. And that then can cause all these smaller earthquakes to finally rupture and release. So this is almost indicating that there is like a bigger pulse of energy coming up. And because we haven't seen this whole big like fracture sequence afterwards, an earthquake swarm afterwards, it's kind of concerning, especially in the context of the fact that this earthquake swarm is almost identical to what occurred before the Great Tohoku earthquake, like almost identical. And similar geologic settings are going to behave similarly across time. That's the thing. We're not comparing this to some far distant flung region that's totally different geology. This is identical in the geology because it's the same location. And it's not 10 million years into the future. It's only 15 years ago. So that's why when they look so similar and the space weather factors are the same, that we really need to pay attention. We really need to pay attention. And to all the people, I would just say very quickly, to all the people that are saying, you're a dummy, like there's no earthquake in Japan that's going to happen, you're saying a whole bunch of nonsense. Well, based off the forecasting, we just had the earthquake in Japan. So we need to pay attention to this stuff because the people here, millions of people live in Japan, millions of people live in populated areas that are at risk of earthquakes, Southeast Asia. I mean, we have the west coast of the United States, we have places down in Mexico and the Caribbean, we have South America, all across the world. The Ring of Fire, billions of people live in these locations. And we need to do our absolute best to actually examine and find the truth. And not our own preconceived notions or we think we're so cool. Like, what is the actual truth? Can we get to that? Can we help these people? Can we do our best to forecast these events? And on a global scale, space weather seems to be useful for forecasting global trends in seismicity. That's what we've been doing on the channel. Then you can start to look more regionally and get a sense of being able to perhaps forecast more localized, like specific events based off of preliminary activity paired with the space weather factors, and also the larger regional trends or global yearly trends in earthquake energy release. So just zooming back over here really quick, there hadn't been a magnitude 8 earthquake in 4 years up until that magnitude 8.8 earthquake struck Kamchatka. The last one was in August of 2021. So it would be four years basically without a magnitude 8 plus earthquake. And typically get one every year. That is the reoccurrence interval for a magnitude 8 or greater earthquake on Earth. Sometimes you get multiple per year, sometimes you don't get any. In 1906, there were so many magnitude 8 plus earthquakes, it's insane. You can look it up. It's the most seismically active year ever on record. We hadn't had any for 4 years. So I started beating the drum back in the beginning of 2025 saying, guys, it looks like we probably have a mega quake coming. Then we started getting some preliminary activity here. And 3 days before the magnitude 8.8, I made a video saying, guys, this is the highest risk zone that we have right now on the Earth. Magnitude 8.5 or greater is a possibility. And it's a higher likelihood, much higher likelihood than normal. Then 3 days later, we had the magnitude 8.8 megaquake. So that goes to show you how when you look at all these things combined, the rhythmic trends in seismic energy release, the space weather factors, and anomalous earthquake activity that's occurring in zones that can have big earthquakes, how you can actually do this. So yeah, that is how you can do this. Take a couple more questions. And Miss BC is saying, paying attention isn't going to change anything. We can't change what's going to happen. Yes, so we can't change what the Earth is going to do, but we can change how we respond to that. Being prepared, making sure you have some water on hand, some food on hand, knowing what you're going to do. If you live in an earthquake-prone risk area, knowing what you're going to do in the event that something happens, like going underneath your desk or running out to the middle of the street because you don't want to really generally be in a building. So these are things that we can do, and we can be aware of this stuff. And you don't want to live in fear. You just want to live aware and prepared. That's basically what I say. It's better to be aware and prepared than not. If something happens, you're going to be very happy that maybe for like 6 weeks, like anyone in Japan that paid attention to my forecast back a month ago when this swarm was occurring, now I'm sure there are some people out there, right? We have some Japanese viewers. So hello and welcome, Mushi Mushi. They are probably happy that they paid attention to that if they did. And Nana is asking, do you think it odd that all these quakes are missing California as some weird precursor to a big one looming there? Yeah, so just in general, and I've said this before, just in general, people for some reason are overly fixated on big earthquakes in California. They do occur up to about magnitude 8, but California is actually not that seismically active compared to like Japan, compared to Alaska, compared to Mexico. So yeah, big earthquakes can occur here, but it's like this internet fantasy thing for earthquakes to occur in California. I don't ask me why. If you look at the record of earthquake activity in California, the Hayward Fault in the Bay Area is overdue for sure. And then you also get this rhythmic movement of earthquakes across time, but the recurrence intervals for some of these faults is quite long, like hundreds of years. So it's not like California is destined to be getting magnitude 8 earthquakes every 2 decades. That's a little bit too fast. But we are overdue for a big one in California. Where it's going to strike, we don't know. The main things I can point out quickly is that the bend in the San Andreas Fault right here creates a lot of tension. This is where you'll get a big magnitude 7.5 or greater earthquake. And then also you'll notice another bend in the San Andreas Fault down here. This section is also where you can get a strong magnitude 7.5 earthquake. So for example, the last one that occurred, well, 1857 Fort Tejon earthquake did not actually strike under Fort Tejon. It was more to the north, but they call it that earthquake because that's where people were, and the shaking there was still tremendous. That epicenter was roughly like this location. It ruptured the fault going all the way down to LA. And then for the 1906 earthquake, that epicenter was right off the coast of SF, but it ruptured the fault going all the way up to Eureka. So, you know, huge fault rupture. So these things can occur, but their earthquake reoccurrence interval is actually quite long. So the biggest risk right now is probably the Hayward Fault, because that one was back in 1868. I believe it's 1868. And well, now it's 2025. So that one's been a while. But also big earthquakes can strike down in this region. There was a double sequence in 1812 for LA. It was here and then there. And then there was also an 1800 earthquake that struck near San Diego. It's been 225 years since that. So yeah. And I just answered your question, Katie, so thank you so much for the super thanks. And a good question from Tom. The entire North American plate moved after the Alaska quake. Well, the entire North American plate is quite large. It's a big plate, okay? So certainly there was some strong movement here. And what happens is you have to think of it a little bit more regionally. Like this is subduction here going down. So we had like a little bit of a break here. There was some movement there. Those waves rippled out, but all of North America didn't move. It's segmented. So then if there's a big rupture, let's say California, right? Let's say we get a magnitude 7.8 there soon. And the San Andreas really slips. Now you're going to get that big segment of North America to move relative to the Pacific plate. You can get more here at the Aleutian Islands. So, and then there's other plate boundaries here. This is all spreading center though. So here you get active spreading. So this is actually crating land. And then here is where we're getting some strike slip, and here's where we're getting subduction. So the entire North American plate did not move after the Alaska quake in terms of like everything shifting, but in terms of just like a ripple, like a vibration, yeah, that did occur. That Alaska quake caused, you know, a ripple across the entire continent and even going into Europe. A question from Bionic Donkey III, which is, do you think 3i Atlas has increased solar activity? To keep it really fast and simple on that, that's what my intuition is telling me. We see that with comets when they get close to the sun, that we see this increase in solar activity. We know that comets have these electromagnetic characteristics to them because the release of neutral gas and dust from their just nucleus all of a sudden ionizes in space, and that creates plasma. Plasma is super electromagnetic, and the force of electromagnetism is way, way, way stronger than gravity. Gravity obviously is not insignificant, but once you get to electromagnetism, you know, those magnets click together really quick. It's 10 to the 36 times more 10 to 36 more zeros more powerful than gravity. And we also see that these objects can have their own magnetism to them. And so when you get that flying through and there's nothing in between it and the sun, it's going to create a stronger gradient that can trigger sunspot growth, especially if it's solar maximum. We're at the very end of solar maximum right now, beginning of solar, the descending phase. And we saw that these sunspots grew on the sun, and then right as they turned, the biggest ones recently, right as they turned to 3i Atlas, boom, they started exploding like crazy. They turned around. We got a huge solar storm. That was a G5 minus storm that we had recently. And so it's close to the sun. It seems to be connected. That's what I would say. I could go much more in depth on that, and I have in many, many, many videos. But for right now, just to give you my thoughts, yes. I mean, the connection's clear in my opinion. But others could argue otherwise. They're welcome to do so. And Robert Polson is asking, do you put any stock in the core displacement geodynamic rebalancing theory? no, I don't. I have looked into it. This is an idea of how there's going to be a change in basically the rotation of the core and the crust. And so there's like this crustal slip event that occurs. And all of a sudden things shift like 90 degrees or something. And I don't think that's the case. We can actually look to the Earth for evidence of that. If you were to have some sort of displacement of the crust over the rest of the planet, then you'd expect to see evidence of that. And we don't, first and foremost. And instead we see evidence of the opposite. Here we have Hawaii. I'll just keep this really quick. Here we see Hawaii fed by a mantle plume hotspot coming up from the core mantle boundary, okay? So this is really deep structure coming all the way down to the liquid outer core. Well, look at this. You know, right now we have the Big Island, lovely place. We also have Maui, we have Kauai, we have Oahu, right? We have all the islands here. Kauai is the oldest island in this sequence right there. The Garden Island, no active volcanism anymore. Maui still has a volcano. Big Island has all the volcanoes. What's happening is the crust is moving over this hot spot. And maybe there's a little bit of drift to the hot spot, but in general it seems to be fairly fixed. The crust is moving over it because of plate tectonics, right? Well, look at this. Oh wait, we can track this back in time, can't we? Oh yeah, we can. We see how, and there's some jog here, right? But because the plate tectonics change, but we see that this seamount chain goes all the way back, like 45 million years. So if there was a crustal slip event, you would expect that to all of a sudden basically show up somewhere else. And now Hawaii would start forming maybe here or something like that. We don't see that. There's a ton of hotspots on the planet, which you can look at, and their traces across time, okay? I mean, the Galapagos is another one. See some of these seamount chains going off, right? Here's Easter Island. This is the one for Easter Island. Here's the Galapagos. We see these things tracking across time. They've taken rock samples and say this one's 1 million years, this is 2 million years, this is 3 million years. So we don't have any evidence of there being some mantle or crustal displacement event. It's just a fantasy of people that want the world to end. So I don't put any stock into it. And these hotspots prove it very clearly. So I'm going to look at the chat right now. New latest observation is that the tsunami has been observed to about 2 feet. Okay, so thankfully not a big tsunami. And again, that earthquake was quite deep at 44 kilometers, thankfully. So that would explain that. And also, you typically need like a magnitude 8+ earthquake to get a really big tsunami. Another one here from Chris, magnetic pole shift, is that real or fake? Yeah, so we need to be careful about like the meaning that we attach to words. The movement of the magnetic poles, of course, is real. They're always moving around. But how does that, is that happening right now in terms of it going to lead to an excursion or reversal? We can't say. We don't have strong evidence saying that we're in an excursion right now. We could be at the very beginning of one. That we can't rule out because, you know, at some point you go from 0 to 1. So we could be at the very beginning of it. We're seeing the ultra preliminary activity. But in regards to saying we're like in the thick of an excursion right now, that's another one of these things too, as well. That's just basically nonsense. So let me show you what I'm talking about. Here's Earth's magnetic field. And here we see the reconstructed North Magnetic Pole movement across time going back to 200 AD. How did they get this data? Well, they took a whole bunch of sediment samples from high alpine lakes, and then you can measure the magnetism and the orientation and all that for those magnetic grains that settle in the sediments, and then you can reconstruct these virtual magnetic pole positions as a result. This is us right there in 2025. You'll see our track going down like this, and we had this sudden acceleration, as you can see, going from like, let's say 1950 to 2025, and let me turn off your question there. But you'll see with this reconstructed, and this is less than 2,000 years of data, that we've had similar, very fast movements across similar zones, specifically there. Look at that. That's 50 AD, and then each one of these red dots is 50 years. So, or sorry, 750 AD, that'd be 700, and that'd be 750 AD, 800, 850. So we get these cycles, it seems, in the northern hemisphere, in the Arctic Circle for the magnetic pole in the northern hemisphere, circling around like this across time. So this is not at all abnormal as it relates to that. The magnetic field has weakened, but it's still well within actual normal ranges. And in fact, it's actually still quite strong if you look at the geologic record, both recent and also further back. Here is our total magnetic field strength for the past 50,000 years. So we are right here at this threshold. And you see that, in fact, right now, it's stronger than basically the entire past 40,000 years, 50,000 years. A little bit stronger there about 10,000 years ago. It's actually about the same strength then and now. But we were coming off of an extremely strong magnetic field, 1,000 and also 3,000 years ago. That's 3,000 years ago. That's 1,000 years ago. It was extremely strong. Now, could that mean that maybe it's time for us to actually scoop down and do a flip? Yeah. But to say conclusively that we are in one right now is too early. We can look at this, we can track it very closely. We want to be mindful. Same thing, same message with the earthquake stuff, right? We want to be very mindful, but to say definitively we're all doomed, we're not. As of right now, everything is well within normal parameters. And that's the last question I'm going to take on these kind of crazy ideas. And Elijah's asking, can you speak more about the connection of solar storms to earthquakes? Is this happening more since our electromagnetic field is low, the future? And we have this one from Lego here. Predictions for the Cascadia subduction zone. I'm going to do that one first because Elijah, I talk about that all the time. So just watch my videos. I'm going into the details on that. And I actually have specific videos talking about that as well. So I recommend you look at those. But if you just subscribe and watch the channel over time, I go into that connection. I did earlier in this video too. So you can, for example, just watch the beginning of this live stream. And then also, if you are interested, I would go here and I would to the live stream page for me and watch this video because I put out an earthquake alert. 4 big earthquakes could strike soon, December 2nd, right there. We talk about it right there. That answers your question. So thank you so much for the super thanks. This other one here, what are the predictions for the Cascadia subduction zone? That is definitely a big one. That was a magnitude 9 that occurred off the coast here in the year 1700. And I don't like to call them predictions. I think it's more better to be a forecaster. Assign probabilities to the likelihood of events occurring based off of historic knowledge, based off of understanding of the factors, the geology, the geophysics, and in this instance also the space weather factors. Cascadia could pop at any moment. It could pop at any moment. We just don't know when that's going to occur, but it could go at any moment. It's really difficult to forecast it beyond that for right now because I mean, we have the space weather factors, which make all these faults more likely based off of, what I talked about, the solar wind density and things of this nature. But we haven't really had preliminary activity here. That's the thing. I mean, we've had a little bit. If I can modify this search here, you'll see what I'm talking about. And let's draw it specifically for the map so the thing doesn't go totally crazy on us. So I'll show you this preliminary activity that we've been having, but it hasn't been exactly in the same area. And here we go. So here's all the activity that we've had in this bounded box. You'll see our largest earthquakes are this 5.9 there, Bandon, Oregon, 5.7. These are all along the spreading center. So we haven't had any preliminary activity, let's say like in a section like this, which would be indicative of that subduction zone. Instead, it's all been along the mid-ocean ridge. And you get magnitude 5s and magnitude 6s on mid-ocean ridges. That's not anomalous. If you get up to a magnitude 6, it does start to get a little odd, but they do occur. But that's a strong earthquake for a mid-ocean ridge. The strongest that I've seen is the 6.6. And that was earlier this year on March 28th, same day as the earthquake in Myanmar, Burma, the 7.7. But so we've had a little bit of activity here this year. I mean, we could cast the net further out back in time to get a better sense, and I'll do that. I haven't done an exhaustive look at the Cascadia region, so I'll go ahead and do that. But the last big one, magnitude 9, was in 1700. So it's 100% ready to go. Just the question is when, and I would say we'll probably see some sort of like preliminary activity that's going to give us a clue. Probably. That's what we generally see, some sort of preparatory activity saying, hey, I'm about to wake up. Get ready, folks. So if that happens, I'll let you know. Of course, subscribe to the channel. Hopefully it doesn't happen in my lifetime. Thank you, Trish, for the super thanks. We appreciate you too as well. And thank you also, Shakes, for the 10 quid. Thank you for being you. I like other people who are interested in things I am, the seen, the unseen, the science, and the scientists and the faithful, the past and the present. Yes, thank you so much. And because we have so many people watching right now, I'm just going to do a quick recap as to what has happened. Give you guys the TLDR really quick. Okay, so we have had a magnitude. Let's just set this up correctly, okay? Here we go. We have had a magnitude 7.6 earthquake rupture off the coast of Japan. You'll notice that the aftershock activity has been extremely low with only a magnitude 5 and 5.5. This is striking right near the location of the earthquake swarm that occurred off the coast of Japan a month ago, which was defined at its maximum by a 6.8 and a 6.4 earthquake. These were shallow. This one's fairly deep, 44 kilometers. That's not super deep, but it's deep enough that thankfully there wasn't much of a tsunami from this. So the tsunami threat alert was issued for this. The tsunami wave height was estimated to be 0.3 to 1 meters in height above the normal tidal rhythm. And the initial estimates for that coming in are that it's about 1 to 2 feet tall, so less than a meter. And then that was specifically for the coastal regions of Japan going up to parts of Russia, and everywhere else the alert was much, much lower. So thankfully this did not result in a devastating tsunami. This is a big earthquake, but it's not a like a mega quake such that it's extremely devastating. I'm sure if you go online, you'll be able to find footage of the rumbling from these towns here and probably even further afield. I'm sure the residents of Tokyo also felt that 7.6, but it wouldn't have been devastating for anyone in Tokyo. It would have to be like right there for that to be a problem. And Tokyo also being right here at this triple junction, that's not good. But that's a different story. So 7.6 in Japan. Following up on this anomalous swarm here, which is almost identical to the swarm that occurred just before the Great Tohoku Earthquake, magnitude 9.1, March 11th, 2011. That also had a foreshock sequence like this. The difference now is that we have this 7.6 here, whereas before the Great Tohoku Earthquake, we had a 7.3 as the strongest foreshock. So this could be indicating something even bigger coming. That is certainly possible. We could be looking at a magnitude 9 or greater earthquake in the near future. We don't want that to be the case, but it's a high likelihood. I would say it's getting close to 50%. I say it's a really high likelihood that we get something big there. Because we were forecasting a big earthquake to strike Japan. I released a video on this a month ago, and boom, we got it, 7.6, based off the space weather factors. Our solar wind density right now is at low levels, lower than 1 particle per cubic centimeter, which is a variable that we track for this. We are exiting out of a coronal hole high-speed stream. We also had this magnitude 7 earthquake just a couple days ago, border of Canada and Alaska. Look at all the earthquakes that occurred after that magnitude 7. This is more typical of a big earthquake and then the aftershocks that occur. If we go back to Japan, bigger earthquake, we've only had 2 lousy magnitude 5 earthquakes to occur there afterwards. So that is bizarre. This is very anomalous. The same thing occurred with Alaska. We go up to Alaska. Check this one out. Here is our magnitude 6 that occurred in Alaska. What was the day? That was the 27th of November. So about 2 weeks ago. And this is all that we had for aftershock activity. Just the magnitude 2s. Basically 3.2, 2.6, 2.9, right? Now this isn't exactly nearby, but it's the same broader geologic setting, the same energies affecting that part of the plate, and then less than 2 weeks later, magnitude 7 with all the aftershocks. So that's a foreshock with anomalous aftershock activity, aka very low activity, and then we get the main event. That's a very clear 1-2 combo that we can look at right now that's relevant to what's happening here. Because here we have an earthquake swarm almost identical to the magnitude 9.1 Great Tohoku. Now we get a 7.6 to occur just to the northwest of it, the northwest, and well, we could be looking at something really big to occur. We hope not, but we could be. This really is serious, folks. This is not. We're not joking around. We're not here just to make up fantasies about some Culebra event that's going to split the earth asunder. You know, these people make up these fantasies. We're interested in reality here. And this looks this is very concerning from a professional geologic and geophysical and space weather perspective. This is very concerning. So that's the update. That's the update for you. We've been having some solar activity. We have solar storms inbound, and we can see that right here. We have this big explosion that occurred on the sun. Here we'll actually see that explosion from an 8.1 M-class flare right here. There we go. Look at that. That's the shock wave, and that's the wider view of that headed towards Earth. We have more solar storms inbound after this. So we have a pretty significant geomagnetic storm coming in less than 24 hours. G3 levels expected. Now with these new solar storms coming in, I wouldn't be surprised if it's a longer duration G3 storm, maybe even a little bit higher. So there's just a lot happening right now. And then I guess, I should really close with the final thing. Something that we've been tracking for more than a year now. The moment this was brought to my attention, I started to pay attention to this. Let's do this. There we go. Okay. Here we have our solar system, and we're looking at the geometry of the planets. The planets are not to scale. This is an application. You actually want to be able to see them. But the distance from the sun and their relative positions is all accurate based off of where they are actually now. You'll notice that Earth, Mercury, Venus, Mars are all, kind of forming a line. Starting to form a line right now, December, right? We go back to today. They're like here. Jupiter's over there. Watch this. I go like that. Boom. We get a perfect alignment of these planets early January of next year. Specifically, January 6th through the 9th is like the key window. If you look at it from a heliocentric perspective, it's really the 9th of January that looks nice. But the Cazimi with Venus and Mars with the sun is on the 7th of January. Jupiter opposition is on the 10th of January. And Earth will be at its closest in its orbit to the sun on the 3rd of January. I think it's the 3rd or the 4th. That's its perihelion. So there's not much variation in the orbit of the Earth. It goes from 0.98 astronomical units to about 1.01. But it will be at its closest to the sun right in this time frame. It always is in January. It very slowly moves in that position. And then we get this planetary alignment, and we see often big significant events that occur with planetary alignments like this. So we do have that coming up. Stronger gravitational forces, electromagnetic forces, and also things that we simply don't know we don't know. But there is obviously more to this universe and our cosmos than we currently understand. The planets are a big component of that. The other big force right now too is Saturn and Neptune are conjunct. In their great conjunction, this is a 1 in 36 year transit. So this does not occur all that often. To have this great conjunction between Saturn and Neptune at the same time that we get this alignment here is quite notable, like quite rare. And then if we zoom out further, you'll notice that Uranus and Pluto are harmonically connected and geometrically connected to Neptune Saturn. This is a 60-degree angle, and that's a 60-degree angle right there. So everything is basically positioned in a mathematically coherent way. This is all geometry, and the secrets of the universe can be thought of in terms of frequency, vibration, resonance, geometry, all that stuff and more. So we have this coming up soon. That's kind of the last thing to be aware of as it relates to what we have coming forward. So I've been your host, Stefan Burns, geophysicist, geologist, space weather guy, cosmic bro, wishing everyone in Japan well. Hopefully everyone's fine. I'll do a assessment of the situation there after this live stream, and I'll probably come back with another video very soon. Maybe not today, but tomorrow we'll have more information. And we'll have that solar storm coming in the next 24 hours. So if you want to stay up to date, then please subscribe to the channel. I release videos almost daily. So we cover earthquakes, volcanoes, geostorms, severe weather events, solar activity, space weather, planetary resonances, comets, interstellar forces, cosmic events, and more. If you like the sound of that, then please subscribe. Wishing each and every single one of you well. Thank you all so much. Say your prayers for Japan. Let's just do that really quick, just to do a collective prayer while we're all here. So, dear God, please protect the people of Japan from any effects from this earthquake, from devastation, from something larger occurring, and protect all the people on this planet anywhere in disaster zones. May we all be safe and protected, and may we be reciprocally your protectors as well in this cosmos. Thank you. Amen. All right. I'll see you all very, very soon.